Hi everyone, welcome to the second video of Module 9. So the first step in understanding the convolutional neural networks is to understand the images in the first place. So that's exactly what we are going to cover in this video, starting by understanding what are pixels, what are 8-bit unsigned integer pixel range, then what are the dimensions that is considered with respect to the images, and then what is the difference between the grayscale image and the RGB image. So let's get started. So let's talk about what is an image and how do we deal with different type of images with Python. So image can be converted into array of pixels. Okay. Now what are these pixels? In order to understand that, I've given one figure on the right hand side. Here we are having a bird and we are trying to zoom into the eye of the bird. And zooming into the eye, you can see this kind of small kind of squares you are able to see over here. If that kind of squares are still not visible, I'll further zoom in and get to this particular part. This part is zoomed in 1, 2, 3, 4, 5, 6, 7, 8, 9. Small 9 squares are zoomed in over here. And this one small box that you are seeing, that box is what we call it as a pixel. So what amount of shade of different colors is represented by that small square is what we represent with the help of a number, and that number will be a pixel over here. So if you are having any kind of image, you can use Python to read that image, and once you read that image, you get this array of pixels where all the numbers will be written in the range of 0 to 255 if we are talking about an 8-bit unsigned integer. Now what do we mean by 8-bit unsigned integer image? So over here we know that each pixel can either take 0 or 1, either white or black. Just think it in that way, either white or black. So like this, if we are having 8 different possibilities where they can have either 0 or 1, so how many combinations are going to be there? You can do 2 to the power of 8 and that will be the total number of combinations, and that will end up into 256 different numbers. So starting from 0 and going all the way up to 255, that's going to be a total of 256 different shades of a particular color. So let's say if I'm talking about what kind of red pixels I can have by looking into this image. For that, I'll be requiring a red filter in my sensor to capture that object. So on the basis of, let's say, 8-bit unsigned integer image, you can have 256 different kind of shades of red that you can have in the image. Let's say if you are going to increase this particular thing, that is if you are not going to use 8-bit unsigned integer, let's say you are going to use 16-bit unsigned integer image. In that case, you have more shades and therefore more vibrant image you will be getting, right? So I hope you are getting this concept of what is the meaning of 8-bit unsigned integer, or if you just increase the number of bits, more and more vibrant colors you will be able to see because of the multiple shades that are available. It will be 2 to the power of 16. That will be the total number of shades of one single color that you can obtain. Okay. And when I talk about this number of channels, there is one thing that is associated with that. I'll explain that to you in the next slide. But right now, the important part is to understand the meaning of 0 to 255. Okay. So let's just talk about a black and white image. Okay. In a black and white image, we can either have everything like, a black or maybe white or maybe something in between black and white, some kind of grayish kind of tone. All right. So whenever we are talking about 0, we talk about this kind of black or the darkest pixels. And if we are talking about the 255 kind of side of pixels, we are talking about the lightest pixel, the brightest pixel, you can say. Right. So depending on this kind of numbers, we can have what kind of shade of gray will be present in between 0 to 55. If it is closer to 255, it's more towards whiter side. If it's closer towards 0, it's more towards the black side. All right. So that's about understanding what is the pixel and what are these numbers that we use in order to show that this is the pixel number. All right. And this kind of numbers are filled in terms of this array, and that array is nothing but the image that you are going to visualize later on. And the dimensions you just need to focus on right now on the width and the height of the images. Okay. You have rows, columns, and the number of channels, which is going to represent the width, height, and the depth of the image. Okay. Now, after this, I am having a comparison between a grayscale image and an RGB image. If I talk about the grayscale image, it has only one channel. It means it is just different kind of pixel numbers representing a grayscale image. It could be red color, it could be green color, it could be literally any color, but all of this color will be like, for only one typical color, but in different shades. That is called as a grayscale image. Okay. If you're talking about a gray color, so anything that is going to be closer to 0, that will be black. Anything closer to 255 will be closer to white. Just like that, for every color, you can have multiple shades given to that particular color. 0 means the darkest pixel. 255 means the brightest or the lightest pixel. Just keep that in mind. All right. So just for the example purpose, you need to understand that each and every color will come up with this kind of particular pixel of arrays. Okay. So if you are, let's say, representing some kind of image with a 3 by 3 pixel, that is 3 in the width dimension and 3 in the height dimension, then this will be called as a grayscale image. But at the same time, if you are having this kind of thing for red color, green color and blue color, right, individual array of pixels for red shades of color, then green shades and the blue shades, and then if you merge it together in the same order, RGB, you will be getting this kind of a realistic color that our eyes would be able to see, right? So in red channel, we are having all the pixels corresponding to the light coming from the red wavelength, right? Similarly for the green, similarly for the blue. Once all of them are captured with its respective filters, we merge them together, and this is the final output that we are able to see. And that's why in a colorful image, if you are dealing with an RGB type of if you are dealing with an RGB image, you will have 3 different channels, one representing red, second one representing the green, last one representing the blue. If you are dealing with a grayscale image, there will be no individual channels like this. There will be only one single channel image. That's it. And therefore we can either see it as 3 cross 3 cross 1 or 3 cross 3 or whatever is the height and the width. Okay. The important part is the last part, the depth of the image. It's not that we just have RGB or the grayscale. We have different varieties of the color schemes in which we can observe. But in our particular program, we are just going to focus on the RGB or the grayscale. Over here, you need to understand that if I'm just talking about the red array, that red array itself is called as grayscale, similarly for the green and similarly for the blue. If I'm talking about one single particular channel, that can be referenced as a grayscale. But I hope this difference between one channel image and multiple channel image is clear. You can bring multiple channels, you can merge them together and get this kind of a colorful image. But if that colorful image you want to see it as how your eyes would perceive, you can have first your red channel, then the green channel, and then the blue channel. Merge them together, you will see this type of image. I hope this is making sense. So you are done with the first step over here to understand the CNN, that is understanding the images. Now in the next video, I'll be giving you a whole idea of how an example of CNN architecture looks like. So stay tuned for that.